what we're going to look at now is this idea of reactants and products. And I promise I'm almost done talking. This is going to take us 2 minutes, and we're going to need our whiteboards for this one. So when we start talking about reactions, it's really important that we identify the things called reactants, okay? And the reactants are the things that we start with. We then also have things known as products, and the products are like the finished thing. They are the thing that we end up with. Now, we can use word equations, okay, which are equations with words, okay, to name the, again, reactants and products. So in each of these word equations, we're asked to highlight the products. And an easy way for us to figure out what the products are is to look for this arrow. Now, I want you to note that this here is an arrow, and it will always be an arrow, never an equal sign, okay? Now, when we have this arrow, it is starting with the reactants, we have our arrow, and then we have the products. So in this case here, we start with copper nitrate, but we actually end up with 3 products. We end up with copper oxide, nitrogen dioxide, and oxygen gas. In the case of magnesium and hydrochloric acid, we add those 2 things together, and it produces 2 products, which are magnesium chloride and hydrogen gas. Now, chemical equations are very similar, okay? Chemical equations are quite similar, but instead of using the words, we now use the chemical symbols, okay? And so in these 2 chemical reactions, we have zinc plus copper sulfate produces zinc sulfate and copper. So what are our reactants in this case? It is all the things on the left-hand side. Okay. If we look at our next one, and I'll get you to do this right now before I do it, what are our reactants in hydrochloric acid plus sodium hydroxide produces sodium chloride and water? What do we think? What are the 2 reactants? Hydrochloric acid and sodium hydroxide. Okay. So here's what we're going to do. Okay. It's really important for us to note that we can't change what we have at the start and the end of a reaction. We are always going to have, if I put 1 sodium into a reaction, I'm going to end up with 1 sodium at the end of a reaction. But what sodium is attached to might change. So in this case, it means that the mass of the reactants is always going to equal the mass of the products. Okay? And it's using this understanding of the law of conservation of mass that we can balance some chemical equations. So what does this mean for us? Well, it means that there are 4 main rules. Number 1, as we just mentioned, both sides of the equation must be equal. So we need to have the same number of atoms on both sides. We then balance all of the elements first, then hydrogen, and then oxygen. So I'm actually going to write that down the side as number 1, we do all of the elements. Number 2, we do hydrogen. And number 3, finally, we balance oxygen. Okay. Now, we can cheat a little bit with some of these, and I'll show you this in a second. If there is a polyatomic ion, so something where we have lots of atoms grouped together, we can group the atoms together and balance these atoms as a group. And the final rule, which is another little cheat for us to make our life a bit easier, is if there's an odd number of atoms on one side and an even number of atoms on the other, multiply the odd side by 2. Because what do we end up getting every time if we multiply an odd number by 2? We end up with an even number. Okay? So what we're going to do right now is we are going to, sorry, I'll zoom out a little bit there for those still highlighting. We're going to write this first equation. So magnesium plus hydrochloric acid produces magnesium chloride and hydrogen gas on your whiteboards. And can you write it just across the top, stretching the whole way? You're going to want to space it out a little bit. So I'll do it over here as well. So equation number 1 is magnesium plus hydrochloric acid produces magnesium chloride and hydrogen gas. So can you please write that across your whiteboard right up the top for me, please? Notice how I've left a little bit of a space between everything, and we'll go from there. All right. So, our rules, as a very quick reminder, we're going to go through them step by step. Both sides of the equation must be equal, and we need to balance everything, then hydrogen, then oxygen. So, do I have hydrogen in this reaction anywhere? Do I have hydrogen in this equation? Yep. Do I have oxygen in this equation? No. Great. So what we're going to start with is, and I like to do this in a slightly different colour. I know you've got the one colour. It doesn't really matter too much, but I just want to make it clear up on the board. I'm going to start with all of my elements, okay, that aren't hydrogen and oxygen. So on the left-hand side, what's my first element that we can see? Magnesium. So below the arrow, right in the middle, below the arrow, I'm just going to write Mg like this. Okay. Next, excluding hydrogen, what is my next element on the left-hand side? Chlorine or chloride, Cl. And the final element for us then is hydrogen. Now, the great news for us is we're going to have all the same elements on the left-hand side and the right-hand side. But the thing that we really want to check right now is that I have the same number of things on the left as I do on the right. So when we have a look at the left-hand side of this equation, so these are called the reactants, okay? So maybe I'll write that just above here to make it clear for us. So reactants on the left, products on the right. How many magnesiums do I have on the reactant side? 1. And so all I'm going to do is I'm going to write a 1 towards the left of magnesium. Okay. Next, how many chlorides, how many chlorines do I have on the reactant side? 1. And finally, how many hydrogens do I have? 1. Okay. So I've got 1 of everything over on the left, over on the reactant side. When we look at the product side now, I start again with magnesium. How many magnesiums do I have? 1. So I write a 1 over here. How many chlorines do I have? How many chlorides? 2. And so I need to write a big 2 there. And finally, how many hydrogens do I have? 2. Okay. So right now, if I was to look, and I start at the top and I look, is the number of magnesium on both the reactants and product side the same? Yes. So I can put a little tick next to it. And I can say, you know what? Magnesium is all good for now. I then have a look down and I look at chlorine or chloride. Okay? And I can see that I've got 2 lots of it on the right and only 1 on the left. And this tells me that I need more chlorine over on the left. Now here's what I can't do. I can't magically put a 2 down the bottom, because this turns hydrochloric acid, or HCl, into H and 2 lots of Cl. That's a very different compound. But what I can do, however, is and this 2 now tells me that I have 2 lots of hydrochloric acid. So it's the same as having a HCl and another HCl. And what this does is it tells me that I now have 2 lots of everything here. So how many chlorines do I have now? 2. And what I can do, and the reason we use our whiteboards, is we can erase that and we can write a big 2. But notice how it's also changed the number of hydrogens for us. And the number of hydrogens has now changed from 1 to 2. And so I need to erase that one as well. I'm now just going to double check. So I've got chlorines. How many chlorines on the left? 2. How many on the right? 2. So this gets a big tick. How many hydrogens on the left? 2. How many on the right? 2. Is that all balanced? Yes. And the final thing that I like to do, I know I've just checked chlorine and hydrogen. I'm going to double check magnesium. Do I have the same number of magnesium on both sides? 1 and 1. Yes. Now the reason that we check year 9 is that these numbers can constantly change. But as of right now, this one is done. So here's what you're going to get 2 marks for in a test. You do this on your whiteboard. You don't do this on your test paper. Okay? And then when you get to your test, all that you need to do is write out that equation. And the only thing that we did here was we put a 2 out the front of HCl. Congratulations, you've just got yourself 2 marks for that. Okay? So here's what we're going to do. If you're getting this pattern, I'm going to encourage you to jump ahead whenever you like, but as of right now, can you erase the example that we just did, and you're going to write Mg plus O2 produces magnesium oxide for me up the top. Okay, so that was number 1. Let's move on to number 2. So magnesium plus oxygen gas produces magnesium oxide. So can you write that one up the top of your whiteboard for me, and then we'll balance this one and we'll do the next one together, and then after that I'm going to let you go and give it a go yourself. So as I'm looking around the room right now, my advice to all of you, try your best to space them out. If you clump them together, it can make it quite tricky for you to write those numbers and make it really clear for yourself. So make sure you give yourself a little bit of space, make it nice and easy for you. Okay, so let's start. Above the arrow, I need to first write the 2 elements that I have here. What element do I write first, magnesium or oxygen? Magnesium, very good, we follow the rules. So magnesium followed by oxygen. Now, how many magnesiums do I have on the left-hand side right now? 1, so I write a 1 here. How many magnesiums on the right? So I write a 1 on the right. How many oxygens on the left? How many oxygens on the right? Great. So right now we can see that magnesium is balanced. Tick. Okay. What isn't balanced, however, is oxygen. So what do I need to do in order to make the number of oxygens balance? How do I balance them? What can I do? Yep, I can get another whole lot of magnesium oxide, and so I can put a big 2 out the front. And now I've got 2 lots of magnesium oxide. I haven't changed what the chemical is, I've just gone and I've found another version of that chemical. So when I look at magnesium oxide, I've now got 2 oxygens. But here's the trick, everyone. While the number of oxygen is now the same, what have I now done to the number of magnesium when I've put that 2 out the front? I've doubled it. And so my magnesium is no longer balanced. It's now 2 to 1. So what can I do to make the number of magnesium balance? I can't delete anything. I can only go and find more. So I go and find another magnesium reactant, and I put what out the front? 2. I put a big 2 here. And this tells me that right now I now have 2 and 2, and I can put a tick there. So now, is my equation all balanced? Yes. So I've got the same number of magnesium on the left and the right, and I've got the same number of oxygen on the left and the right. So all I'm going to do is I'm going to go back to my equation here, and I'm going to fill in, I needed 2 magnesium and 2 magnesium oxide. Okay. So for our final one, let's just do number 3, and then I'm going to let you go and do it yourself. Okay? So number 3. Sulfur dioxide and oxygen make sulfur trioxide. So I'm going to scroll down a little bit here. So number 3, sulfur dioxide plus oxygen gas produces sulfur trioxide, SO3. So can you write that along the top of your whiteboard? And then we'll do this last example together. So if you're feeling confident, feel free to jump ahead, okay? But let's go right now. So number 1. Above the arrow, the only 2 elements I have are sulfur and oxygen. So I start by writing sulfur, and secondly I write oxygen. Now the trick here, everyone, is sulfur on the left is nice and easy. I've only got 1. Sulfur on the right, also nice and easy. I've only got 1. Oxygen, however, is a little bit less nice. Oxygen is actually found in 2 different places. So I've got 2 oxygens in sulfur dioxide, and I've got another 2 oxygens over here. So how many oxygens do I have altogether? I have 4. When I then look at the number of oxygens I have on the right side, I have 3. And here's where we're going to use one of our final rules. Okay? If we go back to rule 4 that we had earlier, if there is an odd number of atoms on one side and an even number of atoms on the other, try multiplying the odd side by 2. So what we're going to do, when we have a look at this example, we're going to multiply the odd number by 2. So is that the reactants or the product side? The product side. So I'm going to multiply everything by 2. And what that does is it changes the number of sulfur and the number of oxygen so that I've now got 2 sulfur and I have how many oxygens? 6, because I have 2 lots of 3 oxygens, so 6. So now this has unbalanced my equation. I have to give me a little bit more work to do. So I need to go and figure out. I need to double the number of sulfur somewhere. Where can I double the number of sulfur? There's only one spot on the reactant side. It is in SO2. And so what I'm going to write out the front of SO2 is a big 2. It then changes that number to 2 for sulfur on the reactant side. And it also changes the number of oxygens I have. So let's double check oxygen. I've now got 2 lots of 2, which is 4, plus another 2, which is 6. And so altogether, I now have 6 oxygens. So I now double check everything. I'm checking sulfur, 2 and 2, happy, and I'm checking oxygen, 6 and 6, also happy. So this gives me my balanced final equation. So I go back to this one over here, and I'm going to fill in 2 sulfur dioxides, 2 sulfur trioxides, and everything is nice and balanced.